then you may be able to delete the lower channel and only provide the password to the 5G one.
That's a good idea.
Hi, Mike.
Hello.
All right. Let's get this show on the road. We have tons and tons of updates to give. Probably one that's uppermost in everyone's mind was, did the burn on scheduled for the 15th happen? And it didn't happen on the 15th. It happened on the 17th. That's because I was blindsided by an issue. But it did happen on the 17th. I don't know, about 6 in the morning. So 129 million rocks were burned. And the transaction has been recorded. I think Ed posted a link in Skype. If not, we can post that to announcements. So as per our promise to the community with respect to the redemption process, that piece is completed. And so every obligation that I am aware of has been met. So thank you all. And now it's time for us to execute. Any comments or questions about that before we move on to other fun stuff?
I did want to queue up a discussion about the staking token supply in the future.
Okay, yeah, let's go ahead. I mean, since we're on tokens, why don't we go with the flow? So how did you want to talk about that?
Oh, okay. Yeah, hi everyone. I've been talking to a number of investors over the last several weeks, and a few of them in particular are asking about the future supply of revs or other staking tokens. And Greg and I went through one iteration that I think covered even last week during this hangout. But there remain to be some outstanding questions. So I'll paste the link of where we're documenting the intentions, and then I'll also share my screen. And the questions are about from an investor or other stakeholder in rocks. Several of us on the call are getting some of our pay in rocks. And rocks will convert 1-to-1 to rev at the time that RChain launches. So that much is clear to people, but there's other questions, and that's what I'd like to go through. And from an investor's perspective, whether it be some of us holding rocks personally, or in someone buying equity in the holding company, and the holding company owns rocks, so they want to make sure that those are going to remain protected. Is, well, how do they know that more revs won't be issued after the go live, or more other staking tokens won't be issued, and that essentially change the percentage of what compute power and investment they have in the future. So let me share the screen. That's the context for this. Yeah. So and some of you might be better to look at the link I pasted here. But so a lot of these there's no controversy, but mainly it's about the supply. But we'll also cover some of the things that Greg mentioned post burn. So question one: there's a million rocks, although some are now unspendable. A billion. Sorry, a billion. I always got those confused. Just kidding. No additional rocks will be created. The contract address is here, and you can see all the transactions. Number 4, and I've updated this distribution after the burn. Still with the co-op is about 86.2%, and then the rest is either with holdings or in individual hands. And then number 5, will any rocks be burned to just supply? And Greg, as mentioned, the 129 some million rocks were burned. No other burn are planned. number 6 is about the AMP proceeds. Greg, feel free to comment on that, but that's really not what I wanted to cover.
Yeah, let's stay on topic for now.
7, what's the budget? Probably needs some work in the budgeting area, but that kind of has to be discussed, I think, internally first. And we really haven't talked too much specifically about the budget either from, but I know Lisa, Greg, and others have Navneet and I helped with this on staffing forecast, which is the primary driver of budget. Schedule, we're running a little bit behind on closing the Series A and getting that lined up. So there's a possibility this may move into early Q4 because this Q3 of 2018 estimate was based on closing in Q3. Let's see. Then this is the big question. We may need to split this into several. I'm not going to read through all of 9, but or maybe I should. Will there be other native economic tokens? And so we eventually say, yes, there may be. ROCs will convert to Rev on a one-on-one basis. We distinguish staking tokens versus other economic tokens like similar to ERC20 tokens on Ethereum. And then if the staking tokens were to be added, what would be its phlogiston rate relative to Rev? And we clarified this last week that Revs will always have a 10-to-1 advantage over others. And so we clarified the language as in terms of the total supply of Revs versus the total supply of other staking tokens, that the total would still be 10 times better, or 10 to the 10th when you do the math of each individual token. So there remains these outstanding questions that I have in comments here. I'll paste this into the document just so those following along can see it for the meantime. So right before 11, I'm pasting some questions I'd like to answer interactively here. Which are, beginning with, what will be the total supply of Rev? So will it be, 1 billion minus the, whatever the number burned was? Greg, you there?
Yes. So I was just saying goodbye to Natasha. Say again?
Yeah. So, some of the open questions that are in my mind that would help address the investors' questions is, what's the total supply of Rev? Is it just what's converted, or are there going to be more Revs created at conversion time?
So we haven't talked about the initial Genesis block. One of the things that makes I'm perfectly fine with that supply amount. That's perfectly reasonable. One of the things that makes the whole issuance question complex is because even existing cryptocurrency protocols have issuance as a part of the validation or mining solution. So what we can talk about is an asymptotic cap on total supply, but making that language very precise is harder, because yes, there is. If we take a sort of traditional, it's a funny word in a field that's as old as 2008. But if we take the traditional approach, there is a kind of issuance that happens, and so no, the total supply isn't capped. It depends upon how you look at the supply. If you look at the supply at the end, it can't get above a certain amount, so it's capped. But is there more to be issued? Yep, there's more to be issued. But that's a small amount, and it's asymptotically decreasing. The issuance is decreasing. So that's kind of what makes it a little bit more subtle. But for all intents and purposes, we can treat it as if the supply is capped. And that's, I think, a reasonable assumption moving forward. I don't see any real reason at the current state to contemplate issuing a lot more token.
Yeah. So you part of that explanation, I think, is the design of Casper and validators would be that some revs will, or other staking tokens would be created, fiat style at that time. And that was a new concept to me a couple weeks ago. It may have been obvious to others, but I thought that during the betting cycle, since there's bonding and there's fees coming in through the transactions, that all of that would be distributed among the miners, and additional revs wouldn't be required. Could you elaborate why the protocol requires additional revs to be created?
It's not that it requires it. It's just that it makes some of the maths work out a little better if you're trying to optimize for if you're trying to optimize for certain things. So it's not a hard fast requirement. I think actually Vlad favors a fixed total supply while Vitalik favors issuance. I certainly know that that's what Ethereum is planning.
Assuming that we get that we go with the issuance thing, the question is the effective cap 2 billion, or is it 1.1 billion, or is it 10 billion?
That's a great question, and that's currently what we don't have designed, right? I mean, that's a knob or a dial that we're still calculating with. I mean, my druthers currently is that it's about 1.1 billion, but that depends. What impacts that is the longevity of the protocol, right? So that's but the thought is about 1.1 billion is the total cap.
I think some of the angst there is that I feel like it could be arbitrary. I mean, my view is the details of the mining and the consensus protocol and the logistic, and all have not been finalized yet. And to finalize the cap before those are finalized seems to be unwise to some extent, in my view. And I also feel that the stakeholders, the members of the cooperative, want some ability to consent to the decisions, and I think the cooperative does own the tokens and has that ability to vet the decisions as they are made.
I absolutely agree with you, Jim, on every point. First of all, if any party that wishes to be involved in that part of the discussion, they should join the co-op and engage with the membership and talk to the board. I absolutely agree with you. That's kind of the whole point of the cooperative structure. And I think that you're right that the wisdom is very clear here. Let's not commit ourselves prematurely. Especially if it's going to screw the whole protocol later because we just don't have the headroom. It's like when you're trying to do sound for a show, you got to leave yourself a little headroom. And the same is true here. We got to leave ourselves a little headroom, especially if we expect and intend the network to be lasting the next 50 100 years, which is entirely possible. These are the kinds of things that we have to be thinking about, and why it takes a little bit of time to come to. I mean, gosh darn it! I mean, just negotiating a single safe has taken us weeks, right? And that's a really small number of details by comparison to the total number of details that we're considering when we're considering the design of these protocols. So yeah, if it takes a little time, I think that's all right. But that's why there is some subtlety here with respect to cap versus issuance. Does that answer your question, Ed? I know it was a long-winded one.
I was on mute. Yes, I was, and I appreciate your points, Jim, as well. I think what we should do is, state that this is the intent. I don't really want to hamstring our options here, but the investors need some assurance about effectively the preference that revs will have and continue to have, and that they won't get, their value won't get diluted significantly.
Yeah, yeah. I mean, it's not going to be a multiple greater than 2, right? If I remember the calculations, it should be less than 1. A multiple less than 1,
okay,
which is added to the supply.
Okay, so that's not what I just wrote. I wrote if it would be.
That's 1/10, right? That's exactly in compliance, right? So.
Oh, I thought you said a multiple. Okay, I misunderstood. What a multiple 1 I thought would mean 100%.
Less than 1. So some percentage less than 100% should be the total additional supply created by issuance.
Okay, but yeah, you're saying no more than 2 billion or an additional 1 billion, but I wrote 100 million.
Yeah, right. But that it's likely if I have my druthers and we can make it all work out, then it would be a 1/10. What it means is that the curve has a certain shape, right, over time. So yeah, it's shallower and shallower up at the top end.
Okay, but you agree that the estimate total supply would approach 1.1 billion?
That's if I have my druthers, but we have to mess about with this and see.
So he's saying he would like it to be around 1.1. He is pretty certain that it won't be higher than 2. It's definitely not going to be 10.
Yeah.
And it will always decrease in its issuance.
Yeah, the issuance keeps decreasing, right? But you have to think about what that means in terms of future validators, right? It motivates you to get in the game early, but but what's your motivations later on?
Yeah. Okay. Will the supply of revs be capped? And I'll say yes, see above, or reword that. Okay. Will validators be paid from the current supply of staking tokens, or will new stake? We answered that earlier. Different way. Okay. I think this will help a lot. Greg, we'll talk about this particular investor offline. But I think this addresses their major concerns. We also had other topics in here about listing on, just the one more about listing on exchange, which really wasn't what I intended to talk about today. Any other questions from the audience? Community, maybe is a better word.
From those present.
Yes. Okay, awesome. So my intention is, I'll review the wording for precision. It's probably all good. Renumber this, and ask the cooperative board members to endorse this as an intention. Thank you.
Thank you. No, thank you for driving that discussion, Ed. All of that discussion actually impinges directly upon the development that we're doing. We have some nice updates. Kent, are you in a place where you want to chat about what we've been doing this past week?
Sure thing. Yeah, I got some news, I guess. The Cell 1 contract is now running on Rosette. And so just to give a bit of an overview on what that exactly means, let me just share my screen. Let's see. Does everyone see my screen?
Yes, I can.
Okay, cool. So let me get out the screenshot that Greg posted, I think 2 weeks ago. But so I think it was actually 2 weeks ago when the Cell 1 contract was compiling from Rolang to Rosette here. And so this is essentially the top half of it was done. But now, I guess this week's news is that the bottom half of the Cell 1 contract is complete. And so what we see here is, this is essentially, pardon. I just actually finished this last night, but
working all night.
Anyways, so these I guess 6 lines are basically the Cell 1 contract, and just to give an easier parse, let me start from the Rolang contract side. So essentially, there's 2 methods in the Cell contract. There's a getter and a setter, and then the getter just receives the state, and then the setter just sets the state. And so here, when that compiles down to Rosette, we see that in the form of 2 blocks, or one is this block for the get, and this block for the set. And yeah, so if we just let me just give a demo on the fact that so the idea here is that it's very similar to the hello world.rbl contract that I ran through, I believe, also 2 weeks ago, somewhere around that time frame. But we are creating a new namespace. We're defining the Cell contract itself. We define a printer for it, and then we invoke the Cell contract, and we send it the state first, and then we just get the state. And then the printer is already listening on the channel that the get returns to. And so it will just print that out. And so in theory, like copy, and then let me just switch over to Vagrant. So this is Rosette. And if I just copy and paste what I just showed you, the Cell contract, the printer, and then actually getting the state, then yeah, I'm sorry, that's a whole bunch of debugging output. But the important part here is that it actually prints out the state that I passed in. I believe I can find it around here. Print partially filled. Nope. Yeah. I guess we can skip that till I clean up the debugging output. But there is a state output here somewhere in this debugging statement. So yeah, I mean, there's that cleanup to do, but it should be mostly through. And the Hello World works as before, and also the Hello World produce first. And really, from the I guess from the milestone perspective, the big news is the Cell 1 contract. But really, the more technical milestone news is that like the consume and produce now take multiple channels, and this is essentially what allows the Cell 1 contract to actually run. And I'm not going to dive into too much of the details there, but everything will be on space.rbl if you're interested. And the idea is that before, the consume only took one channel at a time, so to speak, but now it takes multiple, and there's a whole bunch of logic that is related to that fact. And really sorting through all that is at the core of this tuple space implementation. So I don't know, I'm glad I was able to get through that. And there's going to be a lot of testing, but I think that's the update for now. Yep.
That was just amazing. Thank you very much. I just wanted to say it's been a real joy to work on this stuff. This is why I get up in the morning. One of the reasons anyway. And I really enjoyed being able to chat with you about that and about kind of the subtleties of the implementation. We will be running some more detailed tutorials about the subtleties of the implementation, because people should be aware of them. On the one hand, there's a lot more power here than we're talking about, or even that's exposed well in the surface language. On the other hand, there's some natural trade-offs that we believe coincide with the same sorts of trade-offs you find in the physical world. So, for example, we synthesize the sort of what can get a high dimensional state machine when you have complicated joins. So we synthesize that, and we try to do a good job of making an efficient state machine. The state machine is implicit in the data structure, the tuple space structure that Kent is talking about. And so what people will notice is if they do very, very fancy join logic, we will provide the correct state machine. However, it will not run very fast. The more complicated your joins are, the more complicated your join patterns are, the slower your code will run. And it's very, very unlikely that most people really need super complicated join patterns in their protocols. Most of them will end up being much simpler, and so they can write those by hand rather than synthesize the full state machine. And this is exactly the same as you find in chemistry. So referring back to the physical world, yes, it is possible for different particles to converge on each other and have dynamics that are associated with in-party interactions. However, the statistically dominant likelihood is that only two particles interact, which is why most of chemistry is written down in terms of two-party interactions. So it's exactly the same kinds of trade-offs, the same kind of cost-benefit sorts of things that show up here. There's a lot more that goes on there as well. So one of the things that we want to point out is that the code is set up now for the content delivery layer. So the Rolang surface area does not currently provide the content delivery semantics. However, the underlying substrate is ready for the content delivery mechanism that we had in Special K. So this is so we're already sort of busting at the seams in the sense of spilling well past, the work that's been done spills well past milestone 1 and into milestones 3 and 4. And it just turns, and this is kind of the way software development happens. Like if you have a good design, then often you're nailing down solutions to problems that are far in the future, very early in the game if you do it well. Another thing I want to point out is the opportunity for optimization. So let me just do a quick screen share.
Well, before you go there, I just have a quick question for Kent. So you said that this was doing the bottom half of the diagram. Did you have to make changes to the Rosette VM in order to compile the RBL to Rosette opcodes?
Yeah, so to be specific, it's not exactly the bottom half of the diagram, but actually, to answer your question first, no, there's no changes needed to the Rosette's implementation. I just had to add a bunch of helper methods to the RBL library, so to speak, stuff like tuple append and a few other tuple related methods. But what I meant earlier, when it's not strictly the bottom half, is that, well, it actually kind of goes past it in the sense that it actually executes the bytecode and we're seeing the results of it. And it's, when this goes through the whole pipeline, we're just planning to store the bytecode. I'm sure you know this, but just making it clear to the, I guess, the rest.
Yeah, I mean, to amplify Kent's statements. So the compiler has always assumed a target of the Rosette VM augmented with a runtime. And the runtime is precisely the tuple space together with, access to the store when we make this distributed access to the storage layer and access to the comms layer, right? So that runtime is part of that. And what Kent has done is to flesh out the tuple space piece of that, to include not only the semantics necessary for Rolang, but the semantics necessary for the much broader content delivery mechanism. So then moving on to this looking specifically at the contract that Kent was looking. This is I'm not sure if this is cell 1 or cell 2, but they're closely related. So let me just zoom in here so people can see an example of the contract. So this was the contract here. I'll just change the color so you can see. Let me do text color. Make that red. Okay, so that part is what Kent was working on and got running, either this version or cell 1. I don't remember if this is cell 1 or not. But the important point is that state is a parameter to this contract. And as a result, in the sort of naive compilation strategy, this gets mapped onto a channel in the tuple space. However, if you were to wrap this contract in a new, so you can make an outer level contract, right? And so you wrap this contract in a new that makes state a private channel, right? Then the compiler can see that you never send state out here, so it remains private to this region, and that in fact no other party can see state, and so state can be mapped not onto a channel in the tuple space, but to a local variable. And so this is how we do optimization that will make this thing move at quite a reasonable speed. Right? If every single local variable has to be mapped onto a channel in the tuple space, this will be very slow. but the reality is that you can see just through textual analysis, through static analysis, when you have situations where you can take channels like state here and map them onto things like local variables. And that's going to be the means by which we get this up to a high performance general purpose programming language. And that's the aim, is that Rolang becomes a high performance general purpose programming language. So all of this to me is a strong indication of the sort of the synergy of all the architectural pieces, and now we're starting to see some of the benefits that the mathematics is providing to us. Okay, so moving on, I just noticed that Lisa, I just saw you, Lisa. You've joined us. I'd like to introduce Lisa Rice. I don't know if we've introduced her on the Hangout before, but welcome. I think you're muted, Lisa.
Yes, I was muted. So thanks for the introduction, and it's nice to meet everybody. I tried to join earlier, but I couldn't get my phone to work properly, but now I'm all set on my laptop. So really glad to be part of the group.
Awesome. So I just wanted to let everyone know. So Lisa and I have agreed that she'll be coming on in the role of acting CFO for the co-op. She was already acting CFO for Holdings, and is doing such a great job. She's expanding her role and responsibilities, so we're having sort of regular meetings now as a part of expanding the role that HJ and Lisa play in taking over or getting some of the business stuff off my plate. And Lisa and Ed and I met and did some fairly extensive staffing forecasting, and we hope to make that public so people can see very, in a detailed manner the way in which the co-op is spending its resources when it comes to staffing, and then we'll likewise do similar things for other operational expenditures. But it's really great to have Lisa on board and to have more and more people getting involved in just executing the business of being the co-op. So I'm very excited. Thanks for joining.
Oh, thank you.
All right. So let's see. What are some of the other updates? Mike and I are scrambling to get a couple of papers in. We just discovered there was some deadlines for a couple of venues where we think we might have a shot, but the deadline is Friday. Mike, you want to talk about what we're writing and where we're submitting to?
Sure. One of the conferences is on meta modeling. We may have mentioned K-Framework before on these Hangouts, but it's a platform for developing languages and giving them formal semantics as you develop them. Now, Rolang and Rosette, of course, already have formal semantics, but this is a nice way of quickly building an interpreter for the language. But our main interest in it is that once we've got a K description of the language, we can then implement our ladle algorithm on K and take a K description of Rolang or any other term calculus and produce a K description of a typed version of that language that uses our behavioral spatial typing constructions. So that's our intent. We spoke with Grigory yesterday, and we're going to continue working with him on that. So the first paper then is reporting on using graph-enriched Levere theories as kind of a toy K-framework that has very nice categorical semantics, and then explaining ladle as it acts on these enriched Levier theories. I'm sure we'll get into gnarly details when we try and do it on K, but this will at least get the point across and will have easily understood semantics. The other paper is for Express SOS, and Express is a conference about the expressivity of different languages, particularly concurrent languages. And so we're writing up a paper on how reflection, that's the R in Rolang and row calculus, gives you expressive abilities that you don't have without it. So we're excited to try and communicate this to a receptive audience.
Yeah. Oh, well said. I just want to elaborate a little bit on what you said about K-framework. So Mike and I are at the point now where we're beginning to prototype the ladle algorithm itself, as opposed to just the specific instance of the ladle algorithm as relates to Rolang. So we have been looking at different platforms for where to do sorry, I'm a little distracted. I don't understand
of ladle.
Yeah. I don't understand why my camera isn't showing up. Because I have the camera on. Let me see. Anyway, I'll try to fix this next time. Oh wait, hang on one second. I might have it here. Video. Doesn't offer anything else. Okay, well, I don't know why it's not working. But anyway, so we've looked at several. Will do, Mike. Thanks. So we've looked at several different options. So there's a bunch of trade-offs, right? So the trade-offs have to do with maturity of the automated formal proofs platform versus the ability to take the artifacts that we produce there and connect them to the code that we put in production. So, for example, if we were to use Isabelle, Hall, or Koch, it's quite unlikely that the artifacts produced there would have direct links to the artifacts that we put into production. And that raises this trust gap where we have to go, okay, and then a miracle occurs and the code that's in production is somehow related to the code that we proved correct. And we want to minimize that as much as possible. So K-framework is quite interesting in this regard because the academic version is now completely rewritten in Scala. So that's quite interesting. And it has much of the properties that we want. It's different in structure from the commercial version, which is now used by, Boeing, Toyota, NASA, and other major firms on large code bases to catch bugs. That's largely about the execution. So they even though parts of it are written in Scala and parts of it are written in Java, the backend target for the execution is OCaml. So that's kind of interesting, and apparently that's 10,000 times faster than the academic version. So it's a very, very interesting result. But you can't do a lot of the things that you can do with the academic version. Currently, our aim is mostly to prototype the ladle algorithm itself, and then as a byproduct of that effort, be able to run that on a particular K-framework spec of Rolang, and thereby get automated proofs of the soundness and completeness.
So to emphasize, the output of K-framework is an interpreter, but because K-framework is general enough to encompass types, it can also serve as a type checker. So we are not proposing that we use K-framework to generate a Rolang compiler, but rather to generate a type checker that we can then integrate and use with the compiler.
Exactly right. And so one of the things that we did yesterday was we spoke with the principal of K Framework, Grigore Rosu, who's at Illinois, and he's got a research team there at Illinois, and he's also got a team on the commercial side of the K Framework operation. He seemed very excited. He felt that we were doing exactly the right thing by beginning with the formal semantics and progressively hardening that formal semantics, which is what we're doing. So that was encouraging to get to get that kind of feedback. He also seemed quite excited about supporting us. So he said that if there were features of K Framework that either needed to be refreshed or updated or even developed whole cloth, that he would be open to that sort of thing. So that's also good news, because it means that we have people around a platform who the platform is being actively maintained and enriched and developed, and they're receptive to our interests. So that's a very good thing.
He's also eager to have it integrated into other tools like, say, IntelliJ.
Exactly. So that was the other thing that I'm thinking a lot about is making sure that there's a path not only for Rolang, but for the ladle algorithm itself into commercial tools. So one of the things that I want to be doing over the next several years is working with tool vendors like IntelliJ and Eclipse and other major tool vendors, NetBeans, for example, and making it possible that they can participate in this next generation of software development tools. If we get, ultimately, as I've tried to suggest, it would be delightful if the compile chain, as an example, from contract source code all the way down to executing bytecode, could be facilitated through the blockchain. Of course, that's going to require a bootstrap. But if that's the case, then tool vendors can participate in the economic paradigm shift that's happening with the blockchain, which I think is a very, very good thing. So we're kind of laying the groundwork for all of that. And then the flip side is not so much, or not just that they will be responsive to us, but also that we're talking about an algorithm that significantly enriches and enhances the value of K Framework itself. So K Framework gives you this ability to take a formal spec and generate an interpreter, and on the academic side, symbolic execution, and those kinds of things, which allow you to reason about in an automated fashion about your program. What it doesn't do is to generate a type system. And what the ladle algorithm needs at a minimum is a spec of the term calculus, the language, or the virtual machine, which is the kind of thing that you would supply to K Framework. And then in addition, we need a formalization or specification of the collection that you want the results captured in. And so when you add that to the K Framework spec, then you can use ladle to generate the type system. And then again, just as an aside, so that people can see this is a much broader scope than we were talking about. Once you have that kind of capability, you can turn it into a database engine. So all the code that is related or generated in a language like Rolang, for which you have this kind of type system, you can search a repository using those types. And the search algorithm is directly related to the semantics of the type checker. So this is how the next generation of tools can provide an unprecedented level of value for applications. So that's why we're very excited to work with Grigore and the K Framework folks. So I feel like this is a very important step towards realizing some of the co-op's goals and some of Holding's goals. Okay, that was a big, long, deep update. let's see. Anything else? Let's leave it open for questions now. We got about 10 minutes, and see if there's community engagement. Other people who want to speak. Yeah, let's just leave it open.
One thing that I had been thinking about was just introducing some of our guys. Griff McClellan has been hired to work with us. He is possibly going to work on the storage layer with you. Tim Schäuble has just joined us this week, and he'll be working on translating the expression hierarchy in the Rosette VM as his starter project. We've also got Chris Kirkwood Watts coming on later. He'll be working on the comms layer, and we're looking at continuing hiring. So more and more people getting involved with the effort to implement the VM in Scala.
This is awesome. This is really good. I was super, I mean, one of the things that Mike and I spoke about is that Kent has made so much progress that very soon, like in 2 or 3 weeks, the VM reimplementation is going to be the major blocking task, because we need to have that in place before we integrate the storage and the comms. And the storage and comms can continue, but before we sort of connect everything up, the reimplementation of the VM is going to be a dependency that needs to be at a certain stage of completion. So this is great to get the right kinds of folks in there and getting them working on that.
Is it still the intention that, with some restriction, the C++ Rosette will work with storage and COM before?
Yeah, I mean, there should be no reason why it won't. However, the one big caveat there is that once we have the sort of byte for byte reimplementation or bug for bug reimplementation, I will be mucking about with the continuation semantics. So the continuations will be more in alignment with delimited continuations rather than the Rosette one-shot continuations. That significantly extends our feature range for the next foreseeable, at least out 5 or 10 years. So with the C++, I have no plans to upgrade the way the continuations are handled. So that will, fall farther and farther behind.
This week we released the RChain explainer video, which is on the YouTube channel and the co-op and the .io sites.
Yay!
And we're getting closer to a very clear branding document and colors and sort of character sort of feel of the space as well.
Very good. That's awesome. Can you paste a link in the chat?
Yeah, I'll find that.
RChain.coop.
Yeah, just RChain.coop. Yeah, that's the link.
Okay, so
I was comment. Yeah, they had to put this on RChain.com, but before I had a chance to say anything, it was up there almost immediately.
Fantastic.
Yeah, I want to thank Nathan and the animator as well. I think given a pretty limited budget and my insistence on getting it done, they did a great job. This won't necessarily be the last video, and we welcome feedback on it in whatever form, and also what additional videos you'd like to see.
Yeah, and also I wanted to say that we finally closed, or we reached consensus, I think, from the stakeholders who were the noisiest and most attentive to the issue on the name of the staking token, or the first staking token. And that will be Rev. And if there are collisions on exchanges, please correct me if I get this wrong, it'll be REVV on 4-letter exchanges and RVV on 3-letter exchanges. Is that correct? Did I get that right, everyone? Ed, Nathan?
I could live with that. I think the exchanges might be part of that decision too, right? But
right,
yeah,
but
they
that
might
was
dictate that.
Yeah, but that was the agreement that we reached, right?
Right, there's no silent Q.
What'd you say?
What'd you say?
Oh yeah. I was just making a joke. Yeah, it'll be REVV at least at the moment, but we have to sort of be in that discussion.
Right, and then I think Ed has already reserved revtoken.com. So we're sort of shoring up all of the intellectual property, domain and registration, that kind of thing around it. So I'm just excited. Rev is the name.
Also, under the circumstances, since there's a lot of advances going on, maybe I can pair up with maybe Joe or Kent and do some news jacking on the ICOs that have been issuing. Like we can kind of analyze a lot of the problems that are going on, and see how our platform would fix it.
Oh yeah, absolutely, for sure. That's exactly what we want to do, for sure. Yep. Cool. So these are, the pace at which we are moving is incredible. I also want to say next week, Alex Bulkin from Coin Fund will be out, as well as Joseph. And we'll be working in detail on the Rolang tutorial. And we're all teed up, thanks to Kent's efforts. We're all teed up to have a lot of the examples that we're producing be executable. So in particular, the cell contracts are prototypical wallets. So that's very, very exciting for us. I will be traveling from July 1st through July 15th. I will still be on the Hangouts, but headed off to Berlin to do a little bit of development recruiting. Because we're flying Iceland Air, we're going to be stopping over in Reykjavik for a couple of days. But I will be available Vlad is here in Seattle and he's pinging me. He wants to get some lunch. So I was a little bit distracted. But yeah, so that's kind of some of the upcoming stuff. I should probably get back to Vlad. So is there anything else that we want to talk about before I disappear?
I just wanted to mention briefly, I put a link in the chat for the Token Factory. Surge.sh requires a 3-letter token for Ethereum tokens. ROC is available.
Nice.
I think you should get it registered there. They have some pretty nice trading interface and things that, being registered, puts you up there on the, makes the rock more accessible.
Cool. Well, again, we're looking for Rev, but yeah, understood. Cool. Everyone have a great week. I'm looking forward to continuing all this work. This is really, really fun. So talk to you guys soon. Feel free to stay on and keep chatting if there's more to talk about. Was that someone? Okay, cool. Ciao.